So these are the design specification of screening. The inclination of bar is a 45 degree, then bar size of a 10 mm facing towards the flow and 50 mm parallel to the flow. Loss of head through the bar rack. This is the formula of the head loss. So HL is equal to beta in bracket W by B raised to 4 by 3 HV sine theta, where HL is equal to your head loss in meter. Beta is equal to a bar shape factor. W is equal to cross-sectional width of bar facing flow in meter. HV is equal to velocity head V square by 2G in meter. Theta is equal to angle of bar with horizontal. And this is a design of bar type and value of taken a beta. So sharp edge rectangular bar, then value of beta is equal to 2.42. Then rectangular with semicircular upstream face, the value of beta is 1.83. Then circular bar, the value of beta is 1.79. Then rectangular with semicircular upstream and downstream face, the value of beta is 1.67. Then semicircular upstream face tapping in systematic curve to small semicircular and downstream face, the value of beta is 0.76. So another expression which is commonly used for computing the head loss is HL is equal to 0.0729 in bracket capital V square minus small v square, where HL is equal to head loss, then V is equal to velocity of flow through the screen, then small v is equal to velocity of flow before the screen. It should be between 0.15 meter normally and should not be exceed 0.3 meter. So this is the design information of your bar racks. So items head clean, then mechanically clean, then bar size width 5 to 15, then 27 to 75 for head clean, then mechanically clean in mm, then clean spacing between bar 25 to 50 for head hand clean, which is hand clean, then mechanically in the 15 to 75, then slope from vertical in degree 30 to 45 degrees in 0 to 30 degree, then approach velocity in meter per second 0.3 to 0.6, then mechanically in 0.6 to 1.0. Allowable head loss in mm 150 and mechanical clean is 150. So this is a disc type movable fine screen. This is the actual diagram. This is your wastewater, this is your sewage, then collected to the with the scraper. Means this is your disposal method of your scanning. So in this method, then dumping or burning or composite, these are the use. So these are the design of the bar screen. Means to design a bar screen, your design criteria is design a bar screen for a peak flow average 40 mld. So you can assume the following data. You can assume the type of clean is manual, then inclination of the screen with vertical 45 degree, bar size 9 mm to 50 mm, 9 mm facing the flow, then clear spacing of bar is equal to 36 mm, then velocity through the screen 0.8 meter per second at peak flow. And this term can be assumed. Then first we can find out maximum rate of flow is equal to 40 and 40 mld. 40 mld million liter per day. You can convert mld into meter cube per second. So 40 into 10 raised to 6 divided by 10 raised to minus 3 into 24 by 60 into 60. So your maximum flow rate is a 0.463 meter cube per second. So you can find out net area of the screen is equal to 0.06, and this value is be taken 0.463 divided by 0.8, means 0.8 means your velocity through the screen. So the value of 0.5787 meter square. Then gross area of the screen is equal to net area of the screen into 45 divided by 36. If 45 divided by 36 is your angle and inclination bar with vertical and clear spacing of the bar. So value of is 0.7234 meter square. Since the screen is inclined at 45 degree, you can assume the screen is inclined at a 45 degree, then the gross cross-sectional area is needed 0.7234, means gross area of the screen divided by sine theta, and sine theta is equal to your 45 degree. Then 0.7234 means your gross area of the screen divided by sine 45. Then you can choose the angle of 45. Then Your answer is gross area of the screen is a 1.023 meter square. Also, velocity of flow above the screen is 0.8 into 36 divided by 45. Your answer is a 0.64 meter per second. So you can find out the head loss. The formula of the head loss is 0.0729 in bracket v square divided by, sorry, v square minus small v square. This is the same value. So your capital V is equal to 0.8 and your small v is equal to 0.64. So your head loss is equal to 0.017 meter. You can convert into centimeter, is nearly equal to equal. So is nearly is equal to 1.7 centimeter. This will be head loss when screen is clean. So if, however, the screen is half clogging, means your screen is a halfly open, then the head loss of head will be v is equal to 2 into 0.8, and 0.8 is your head loss. Then your answer is 1.6 meter per second. So head loss, the formula of the head loss is 0.0729 in bracket 1.6 square minus 0.60 square bracket complete. Your answer is 0.157 meter. You can convert it into centimeter. So your answer is 15.7 centimeter within permissible limit. So next part is your grid chamber. In short, if you study the screen, you can, your first object is a main object is to remove large size of floating matter. Then types of screen, it may be a score screen, then it may be medium screen, then fine screen. In core screen, the spacing of bar are more than 40 mm center to center. In medium screen, the spacing are less than 40 mm. In fine screen, the spacing is vary up to 1.5 to 6 mm. So our next part is a disposal of screen. So the debuds or the waste material or the large size of floating materials disposal by the following way. So first is dumping. In dumping, the waste material are dumped into low-lying area far away from the locality. Then burning. After drying, the floating material are burnt into the ashes. Then composting. Good quality of manure or good quality of fertilizer may be obtained by composting at compost plant. Okay, so in my side, the screen topic is over. In next session, will be continue. The next treatment unit is a grid chamber. Okay, thank you so much.